So we're going to look at two more root theorems, the irrational and imaginary root theorem. So the irrational root theorem says that for a polynomial, if a plus square root of b is a root, then a minus square root of b is also a root. They're called conjugates. For example, if you have a polynomial equation with rational coefficients and it has the roots 3 minus square root 5 and negative square root of 11, the two additional roots would be 3 plus square root of 5 and then positive square root of 11. Try these next three questions. So we would have negative 2 minus 3 square root 7 for minus square root 10 and negative 1 minus 3 square root 6. So the only thing that's changing is your middle sign, not anything that is in front. The imaginary root theorem is pretty much the same idea, but with imaginary numbers. So for a polynomial, if a plus bi is a root, then its conjugate a minus bi is also a root. So for example, if I have 4 minus 3i, then I also have 4 plus 3i. If I have 2 minus I, then I also have 2 plus I. Negative 2 plus 9i means I have negative 2 minus 9i. And if I have positive 7i, I also have negative 7i. And this in part is coming from whenever we did the quadratic formula, you have the plus and minus in front of your square root. And so you're having the positive and negative versions when I'm doing the square root either of a negative or of an irrational number. This doesn't happen when I have rational numbers, because if it's a rational number, it means that that square root is simplifying. And it's going to be very handy for the next video when we are writing equations of polynomials from their roots.